Let's look at the next simple machine, a ramp. A ramp is just another name for an inclined plane. We use a ramp to make lifting objects easier. To use it, one object is pushed along the length to lift the object the height of the ramp. Like pulleys, we can use distances or lengths to find the ideal mechanical advantage of a ramp. We define the ideal mechanical advantage of a ramp as the length of the ramp, i.e. the part on the angle, divided by the height of the ramp, the vertical part of the ramp. Let's look at this sample problem of a mountain road. Look at the picture and calculate the ideal mechanical advantage of the road. So, with all our problems, the first thing we do is list our given information. Length of the road equals 3,000 meters. Height of the road equals 100 meters. Remember, the height is the elevation, the vertical distance, and the length is the distance that the object actually travels. We're trying to find our ideal mechanical advantage, IMA, equals question mark. Next, we write our equation. Ideal mechanical advantage equals length of the road divided by the height of the road. Now, of course, in this case, the road is a ramp, or the ramp is a road. Then we substitute in our values. The length of the ramp is 3,000 meters divided by the height, which is 100 meters, gives us a mechanical advantage of 30. Again, notice that the units don't make a difference because they divide out. Our final statement, the ideal mechanical advantage of the road is 30. Mechanical advantage and ideal mechanical advantage are of course related. In a perfect world, they would be exactly the same. So, if we assume our simple machine is perfect and no energy is lost, then our measured or actual mechanical advantage would be the same as our ideal mechanical advantage. We can then use this assumption to solve more complicated problems. All right, let's try it. Returning to the mountain road before, let's determine how much effort is needed to drive the truck up the mountain. Again, start with what we know. We know that the ideal mechanical advantage, IMA, equals 30 because we calculated it already. We can also know that the output force on the truck, is 15,000 newtons. We want to find out the effort force or the input force, Fi. Next, we write our equation. Look back at your triangles. We know that Fi equals Fo divided by Ma, the output force divided by the mechanical advantage, which equals 15,000 newtons divided by 30. Then we do the math. 500 newtons. The units are still in newtons because newtons divided by nothing is still newtons. 500 newtons of effort, therefore, is needed to drive the truck up the mountain. Okay, let's put everything together with a lever. Recall, the lever equation is that the ideal mechanical advantage equals the length of the effort arm divided by the length of the load arm. Our regular mechanical advantage, of course, equals the output force, Fo, divided by the input force, Fi. The key is this: if there are no losses, these values would be equal to each other. In grade 8, there are no losses. So, we could then determine the amount of input force that would be required to move an object with the Here's our last sample problem. Look at the lever. The fulcrum isn't in the middle. It's 25 centimeters from one end and 75 centimeters from the other. If we have a box with a weight of 20 newtons on one end, we want to find out what force would be required to support it. Okay, so as always, the first thing we want to do is list all our given information. The effort arm length equals 75 centimeters. The load arm length equals 25 centimeters. We also know the load force, which is the output force, is 20 newtons. What do we want to find? The input force. We can't do that directly, however. We need to find something else first. Okay, the mechanical advantage, ideal, of a lever is what we want to find. It is defined by the effort length divided by arm length divided by load arm length. By finding the ideal mechanical advantage, we can then make it equal to the regular mechanical advantage and find our forces. So 75 centimeters divided by 25 centimeters gives us an ideal mechanical advantage of 3. So this lever makes work 3 times as easy, or 3 times easier. Now let's find the mechanical advantage. Back to our original equation, mechanical advantage equals the output force over the input force. But we don't want it in that form, we want it in the form to solve for the input force. So the input force equals the output force divided by the mechanical advantage. Use your triangle, it will be given to you. So substituting in 20 newtons for our output force divided by a mechanical advantage of 3 gives us an input force of 6 2/3 newtons. Again, we still need a final statement. 6 2/3 newtons of effort are required to support the box given. To summarize, for mechanical advantage there are some equations you will need. This triangle shows how to calculate mechanical advantage. Make sure you take it down. These triangles show how to calculate the ideal mechanical advantage of a lever, a pulley, and a ramp. All of these equations are equations you will need, and all of these triangles will be given to you upon writing a test. Do take note of them and make sure you understand how they work.